Have you ever stopped to wonder how millions of meals get delivered across an entire country all at the same time? Well, it's not just about the delivery riders. It's a total technological marvel. Today, we're going to decode the incredible engineering that powers a giant like Zomato.
So, to really get a sense of what we're dealing with, let's just start with one number: 100 million. What do you think that could be?
You got it. Over 100 million times a day, someone, somewhere, is searching for something to eat. And Zomato's system has to handle every single one of those requests, and it has to do it instantly.
So that brings up the big question, right? How in the world does the architecture behind a system that massive actually work? Well, that's exactly what we're going to dig into. We're going to follow the hero's journey of a single order to understand the high-speed engine that makes it all possible.
It all kicks off the second you open that app, and your craving starts to hit. But, the first and most critical step Zomato took wasn't about adding some flashy new feature. Nope. It was about fundamentally changing its entire foundation.
See, in the early days, Zomato, like a lot of startups, used a single, massive application to run literally everything. This approach is simple when you're starting out, but it becomes incredibly risky as you start to scale up.
And this is what's called a monolith. Think of it kind of like a giant house of cards. A tiny problem, let's say in the part that handles restaurant photos, could actually bring down the entire payment system. And that's a risk you just can't take when you're handling millions of transactions.
So what's the alternative? Well, the answer is microservices. Instead of one big, fragile system, you break it all up into lots of small, independent services. This means you can scale them up or down, or they can even fail without taking anything else down with them. It's all about building a system that's resilient and can adapt on the fly.
And this is exactly what Zomato did. They took that giant monolith and just broke it apart into dozens of specialized services. The huge benefit here is that the ordering service can scale up like crazy during the dinner rush, while the billing service just kind of chills on its own cycle. A failure in one won't cause a total catastrophe in the other.
Okay, so now we've got all these independent services. But how do they all talk to each other without getting all tangled up? This is where we get to the nervous system of the entire platform. And this is where it gets really cool. When you hit place order, your app doesn't just freeze up waiting for the kitchen to respond. Instead, your order becomes a message, an event that gets fired into a system called Apache Kafka. You can think of Kafka as a massive digital shock absorber. And this is the real power of that approach. Your one single order_created event gets picked up by all these different services at the same time. The logistics system starts looking for a rider, while the restaurant system is alerting the kitchen. Everything happens in parallel, which makes it incredibly efficient.
This asynchronous backbone is really the secret sauce to their stability. During huge traffic spikes, like on New Year's Eve, the system doesn't crash. The orders just line up as events in Kafka, and they get processed as fast as the other services can handle them. It just ensures a smooth experience for you no matter what.
Okay, your order is officially in the system. Awesome. Now comes what is probably the most intense part of the whole journey: finding the perfect delivery partner. And this is where the AI really kicks in.
So think about this problem. It's so critical. If the rider gets there too early, they're just wasting time. If they get there too late, you get cold food. Nobody wants that. A simple guess just isn't going to fly at this scale.
The solution is this really sophisticated deep learning model. It's constantly analyzing the kitchen's activity in real time. What's being cooked, what was just finished, to predict the exact food preparation time, or FPT. This lets the system time the rider's arrival pretty much perfectly. So, with that FAPT predicted, the dispatch algorithm gets to work. It's solving a version of the vehicle routing problem, which is this classic logistics puzzle, but it's doing it in real time for thousands of orders and riders all at once. The goal is to optimize for speed, cost, and just keeping the whole system balanced. All right, a rider has been assigned and is on their way. So how does Zomato orchestrate that final, really visible part of the journey, the one right to your door?
That little dot moving on your map? It's powered by a super high-frequency data pipeline. The Riders app is sending GPS data using a protocol called MQTT. It's really lightweight, and it's designed to work great even with spotty cell service. This location data then gets stored in a super fast database and pushed right to your phone, giving you that near real-time view.
So we've seen the journey of an order.
But underneath all of this, there's a foundational layer of data and databases. And Zomato recently made a really pivotal change here that improved performance for the entire system.
They migrated their entire billing platform. Now, this isn't just a small tweak. This is like changing the engine of a plane while it's in flight. They moved from a traditional SQL database called TDB to a much more modern NoSQL database, DynamoDB.
So let's break down why this was such a game changer. The old system, it had to search through a bunch of different tables and then join all that data together to create a bill, and that was just slow. The new system uses this clever single-table design where all the data it needs is in one place. That means it can do one single, ultra-fast query. And, maybe most importantly, this also changed their costs from a high, fixed price to a way more efficient pay-per-request model.
And I mean, just look at these results. This migration led to a staggering 90% reduction in latency for their billing system. 90%. And it slashed their database costs by 50%. This is just a masterclass in picking the right tool for the job to unlock massive gains in performance and efficiency.
You know, this quote from Zomato's engineering team really captures their whole philosophy. The product they're really building is a real-time data platform, and it's one that has to operate at the speed of a customer's craving.
So from microservices to AI to these crazy database migrations, we've seen how Zomato's tech engine is built for hyperscale. And that leaves us with one final question. As 10-minute delivery and instant commerce becomes the new normal, what new architectural breakthroughs